This is the effect of f inverse of x, right? So now that you know what f inverse of x is, the purpose of, let's look at the more technical side of things, right? How, first of all, how do you find inverse? Second of all, how do you sketch inverses? And thirdly, I'll go a bit deeper into why this makes sense. And if you're not that interested into it, you may leave that part. You can completely make do without that part. You can solve questions, but if you want the understanding, that might help, right? So first, let's look at how do you find inverses. So if I have any value y equals 2x plus 3, the way you find inverses is first you make x the subject. Making x the subject basically means x equals to something something, right? And you could think of it as making x equals a function of y, right? So let's make x the subject. Y minus 3 is equal to 2x. X would be y minus 3 over 2, right? Now that you have this, what you do is you swap the x with y. So your final answer would be that f inverse of x is actually x minus 3 over 2. And this is your f inverse of x, and this is how you find inverses. Number two, how do you sketch inverses? Well, let's just draw this, right? So this is what 2x plus 3 roughly looks like. So this is f of x, right? F of x. And one thing to note is that inverses are actually reflection of functions in the line y equals x, right? So if I draw a line y equals x over here, let's say this is y equals x, the inverse function will actually be a reflection of this. It will be something like this maybe. It will be a reflection, and you can go ahead and plot this, and you can go ahead and plot this, and you will get the same thing, right? And the last thing to note is that since they are a reflection, if f of x is equal to f inverse of x at any point, that is if this graph meets if this line meets this line at any point, it will meet at the line y equals x. This is y equals x, it will meet at the line y equals x, right? And this is about it for the theory part. You could say that I would cover in this video. What we are left with are quadratics, mod functions, and composite functions, right? But the video isn't over. I would like to talk a bit about why why finding inverses like this makes sense, why inverses being a reflection also makes sense. So if you're not interested, go ahead and pause or right over here and maybe jump to the next video. But if you are, then let's talk about it. So first of all, why do we find inverses by making x the subject and then swapping the y's, and why is it such uh, that x y goes to y comma x, right? And I've actually explained this part already, that since you're taking the output and then it gives back the input, hence it is y comma x. So let's talk about why we take inverses like the way we do. So if I have y equals 2x plus 3, right? What we are saying is multiply by 2 and add 3. So if I make x the subject, so for example, let me take an example that when x is 1, y is actually 5, right? So we know that 5 is equal to 2, 1 plus 3, right? If I make x the subject, 5 minus 3 over 2 is equal to 1, right? And this is just a specific case. If I just write y minus 3 over 2 equals x, we know that we're basically saying that what at this value of y, what is the value of x, right? And once I swap the x's and the y's, right, once I end up with an inverse, what I'm saying is that at this output, what is the input, and this new input is actually the output. See if that makes sense, right? So if I take if I take 5, right? If I take y as 5, if I know that output is 5, 5 minus 3 over 2 will actually give me 1. And 1 is actually the input that we took too, right? So if we input 1 into f of x, we will get 5, and if we input 5 into f inverse of x, we will get 1, right? I hope this part makes sense to you, that since this is since we're saying that what is the value of input when this is the output and this is the new output, right? If you don't get this, then it's completely fine. You don't really need to know this, right? And the next part, why are the inverses reflection in the line y equals x, right? So whenever you have 2 points, we know that every point on f of x is going to basically y comma x. Is if there's my alarm again. So basically, if you have x comma y, it will go to y comma x, right? And we know this is happening to every point on the line. And whenever this happens, this is actually reflection in the line y equals x. So for example, if this is 2 comma 5 and this is 5 comma 2, this is the line y equals x, right? So if I just connect these two, so first of all, the gradient, so the point A is x comma y and point B is y comma x. If you take the gradient of this, it would be y minus x over x minus y, which is negative 1. And if you're coming from coordinate geometry, you'll realize that this is actually perpendicular because y equals x has the gradient 1 and this is the gradient negative 1, right? So we know this is perpendicular. Secondly, if you take the midpoint, for example, I took 5, 2 comma 5 and 5 comma 2 here. Let's check what the midpoint comes out to be. 2 plus 5 over 2, 5 plus 2 over 2, and it comes out to be 7 over 2 and 7 over 2. We know 7 over 2 and 7 over 2 lies on the y equals x line, right? And for generally for any point x comma y and y comma x, the midpoint would turn out to be x plus y over 2, y plus x over 2, right? And these are both the same number, so we know it lies on the line y equals x. So since it is perpendicular, right? And since the midpoint lies on the line y equals x, we know that this is perpendicular bisector. So basically, this length is equal to this length. Hence, this point is reflected in the line. This point is reflected in this line, and it ends up here. And this happens for every single line there is. Right? So this is the reason why f inverse is actually the reflection in the line y equals x, right? And of course, if they are a reflection, so let's say I have some curve like this, right? And this is y equals x, and then I have some curve. So basically, what reflection basically means is that take this point, whatever this distance is, put it over here, right? And repeat. So when I'm drawing my inverse, it will look something like this. So they will of course meet at the line y equals x because when this graph meets the line y equals x, the distance from y equals x to this graph is actually 0, right? Hence, when you reflect this, this will also meet there. So f inverse of x and f of x always meet at, if they do meet, they meet at the line y equals x. And just to give you an example from above, we know that f of x was 2x plus 3 and f inverse was x minus 3 over 2, right? So if we equate these two, what do we get? 4x plus 6, x minus 3, 3x equals negative 9, x equals negative 3, right? So let's input negative 3 back over there. So 2 minus 3 plus 3 will give us negative 3. So negative 3 comma negative 3, and let's do the same over here. Negative 3 over 2 will also give us negative 3, right? So we see that this has the coordinates negative 3 over 3, and this also has the coordinates negative 3 over 3, negative 3 comma negative 3. So they these two lines, they intersect at the line y equals x when x is -3, right? And this is it for now. Bye bye.